Good afternoon, everyone. Welcome to my presentation about testing in the cloud. Should you be afraid? My name is Csaba Nagy. I work at IT Services Hungary, where I'm a software architect working on network infrastructure provisioning and service management. I'm a former CTO of Uvana.com, which is a location-based ads startup based in San Diego. I started my career as an embedded system developer, building audio and video codecs for DSP systems, and in my free time I love to do Rails. So here's the agenda. First, I would like to cover some basics about testing and cloud and related things. Then I would like to go through all the fears and threats that can come into mind regarding testing and cloud as of today. And at the end, if we have time, I would like to show you a working example that me and my team put together on our project at IT Services. Okay, so about basics. Today, I still see how a conversation going sideways because we do not speak the same language. So I think it's really important to just get everyone on the same page for now, and this will be really short. First off is testing. I guess this one needs no introduction here because we all do testing, right? So everyone involved in software development should be clear on what testing is, how it should be performed. So just for the record, I copied the definition from Wikipedia. It says software testing is an investigation conducted to provide stakeholders with information about the quality of the product or service under test. So in short, this is a process to provide quality. And I'm also working as a developer, so I know that these new development methodologies like test-driven development and behavior-driven development are building on testable code. So they treat tests as the foundation of software development. And so basically, testing is when we translate the business requirements into steps and algorithms understood by the developers and the testers themselves. What can we test? Well, we can do numerous tests, but at the end, what counts is that we test everything regarding the requirement specification. So that is what worked for us. Okay, that's about testing. About the cloud. So today, everything is about the cloud. From personal life to business, it's all moving or happening in the cloud. So one would think that since it became a daily usage, one would need no introduction. But just for the record, I copied the Wikipedia's explanation. It says cloud computing, or the cloud, is a colloquial expression used to describe a variety of different types of computing concepts that involve a large number of computers connected through a real-time communication network, such as the internet. So in short, it's a set of computers or services that provides a single purpose, and usually we treat it as one entity. Okay, so if we think about cloud, we come to Gmail, Facebook, SAP, Oracle, whatever we can think of. Okay, so that was about the basics. Testing in the cloud, what it is. If we Google it up, it gives us 166 million results. That's pretty much. So what it is, why it's important, and how it compares to or how it treats with enterprises. So what it is, we all do tests, and usually we start small. So at the beginning of a project, we usually just use our own computer to do the tests. But as we scale up, like if we are in a team and we have to work on various features at the same time, testing is not scales well with our requirements. So as the more complex they get, the more time they take to execute, and so it takes away time from development, and this is not good. And so this is where the cloud comes in. If you remember the definition, if it's a set of connected computers to do a single task, and so testing in the cloud is nothing more than having a cloud to do our tests or to run our tests. yeah, and helps us solve these issues that will come up with complex testing and yeah, so basically. Why it's important? As I guess Eric mentioned, it takes about up to 40% of a project budget just for testing. So that's one good point already. But today, we usually build for the web, or we build a native application. So when we build something, we can build for example, we have 3 major operating systems in Wild. Usually we have to count with at least 2 or 3 live versions from each of them. We got 3 different platforms, phones, tablets, and desktop. We got 5 major browsers with at least 3 versions to be supported at any time. And if you think about phones, there's 100+ screen sizes that we can count with. Managing this is almost impossible, if you want to do it by hand. And so by using the cloud and smart tools like Puppet, Chef, Vagrant, or Oracle's virtualization technique called, sorry, I won't remember it right now. But anyway, you can manage these, oops, excuse me. So you can basically have some tools to manage these environments on the fly, and you can do them in a consistent way. So for example, if you want to set up a testing environment for a specific browser on a specific OS on a specific platform, you can do that pretty much consistently. So you don't have to have people do that for you every time. And it's also important because cloud is always on, always reachable, and it is objective. So as Harry said, I guess, that technical debt is a major issue right now. And so when we let testers be neglecting or just let them have a bad hair day, we won't get back objective results. And if we have good tests and we run them on the cloud, we will always get back objective results. So they won't cheat us, won't let us cheat. Whoops. Excuse me. Okay, how cloud treats enterprise, how enterprise treats cloud. The larger the company is, usually the less agile it is, and the smaller the company, the more agile it is. But the business demand is always high to be in the cloud or be cloud ready. But there's no out-of-the-box solution that works every time. And there's also the fear in businesses that, for example, security or privacy issues that come up into mind that will risk ongoing business, which of course no one wants. And so if we leave out the natural evolution from the cloud adoption inside an enterprise, we can get into trouble. By natural evolution, I mean we constantly have to get feedback from users, from developers, from operation team. How are we doing on our business needs? Is it achievable what we want to do or not? And so, for example, at ITSH or IT services, we choose the private cloud because we have to be able to manage our own service level times. And we don't want to rely on third parties to do a bad job. Instead, we would like to control what we do and how we do it. But at the same, previously at Ioana, we started using Linode. First we had 1 server in the cloud, then we bought another 15, and then we figured out this won't work because this won't scale up. So we choose to go with Amazon and let it auto-scale for us. Okay, so what comes into mind when we talk about the cloud and testing? And so these are very, very up-to-date questions, I guess. So privacy, security, or trust issues, interoperability, or costs. These are just examples, actually. So privacy, security, trust. NSA, I guess everyone heard about NSA, or the German counterpart, right? The BND, the Bundesnachrichtendienst. Yeah, thank you. Okay, so we all heard what NSA can do or cannot do with our data. And of course, this is bad. So in my opinion, this NSA scandal will push back open cloud adoption with a couple of years, because it will be really hard to make those customers' fears go away. So they just won't, we just cannot tell them that now we're safe, because the NSA won't listen. Because as we read the news, it turns out that even if we turn to Germany, which historically has a pretty good privacy law, we're still not safe because the BND has tabbed every internet traffic inside Germany. Okay, so unwanted access. When we move data to the cloud, we're risking our own data. I mean, we all heard, probably everyone uses Facebook now, and we probably all heard back a year ago there was a scandal about Facebook that if you press delete on one of your photos, it won't get deleted. So if anyone had the link to your photo that you wanted to delete or actually thought you deleted, they could still access it by just entering the URL into the browser. And so if you move your company's data into the cloud, I mean, you're providing unwanted access. Let's just consider Amazon upgrading its Harvard stock. They're changing everything to SSD now. And they just sell the hard drives to someone, to a used port shop or something. And let's say they didn't destroy all the data on it. And all your company data will be got to someone who you don't know, and you don't know what he will do with it. So this is probably a risk that is in the cloud. But should we be afraid of it when we talk about testing? So I don't think so, because as I know, one principle is you should never test on live data. At least you should score it or make it unreadable or something so that it won't, so even if it gets out of hand, no one can really use it. Okay, that was unwanted access. About vendor lock-in. I recently came across a book from Springer. It was published in this year, where there was this sentence about cloud computing as of today lacks interoperability standards, big cloud vendors pushing their own mutually incompatible de facto standards. Well, I have to disagree. Basically, if we take a look at all the open source cloud companies like OpenStack, OpenNebula, CloudStack, Eucalyptus, etc., they are all Amazon AC2 API compatible because they were built to remove your dependency on Amazon. And so I really have to disagree with that sentence, because what I see as a trend is that even though the Amazon AC2 API became the de facto standard of cloud computing, everyone is building on it instead of turning away. And of course, we can also talk about platform as a service solutions for private clouds, for example. Red Hat has OpenShift, Active State has Stackato solution that you can deploy on your own private cloud and have a platform as a service solution. And they are, by default, because of these new languages that we started to use, they are defaultly compatible in terms of deployment. So you just simply issue a git push command and it gets deployed. So I wouldn't be feared of getting in a vendor lock-in regarding testing. So I covered NSA, I covered unwanted access and vendor lock-in, but are these really the important questions for testing? I mean, they sure sound important in terms of security and reliability and trust. But interestingly, the more we test our security, the more sure can we be that NSA won't be able to tamper with our data or won't access our data. The more we security or data test our application, the more sure can we be that we won't have unwanted access on our data. And of course, another solution for these also to use private sealed environments where no one can tap in. So yeah, they are very important questions, but if we talk about testing, we still can be sure that probably nothing bad can happen when we do testing in the cloud. And of course, our fears and threats are what drives building a better and secure cloud in the next stage. So the more we fear, of course, the more better solutions can come up. So I just wanted to assure you that whatever you do, you can migrate between environments, so just stay safe. While this is not exactly true to testing, in my opinion, testing as it is done still lacks a general so-called domain-specific language to describe how we conduct our tests. When I talk about testing, I mean you probably have your own tool, you have a service that you use to do your test, and what happens if you have to move away from that service or that tool? You won't be able to transfer your tests, the ones you put in pretty much money to get into a stage where you are now. And if I would say to you, okay, tomorrow you have to migrate it into another tool, you probably would be doomed. Because there's no common description language to describe how I do my testing, how I do my test steps. And I hope that the upcoming or emerging technologies and developments will solve this issue. Right now, I guess this is the biggest issue that can come up with testing in the cloud, that you're not able to quickly jump from one solution to another. Okay, about costs. I try to avoid this question, but of course the first thing that comes into a manager's mind when we talk about cloud or testing in a cloud is what will cost me. So cloud costs are a bit controversial. If you read the news, you can read that it's not cheap, it's expensive, do not try it. But when you look up Amazon's or Azure's pricing page, you see very low numbers, even something like 10 cents an hour for an instance, and that's pretty low. Just recently, at IT Services, we had a trial to figure out how well these two big companies, Amazon and Azure, would compare to our own solutions. And so we have a team who works with SharePoint, and they have an in-house built-up private cloud system from old machines, which runs 25 instances at 100% uptime. They have 7 small, 50 medium, and 3 large instances. By comparison, the test lab has, at small instances, we have 1 virtual CPU, 2 gigs of RAM. At medium, we have 2 virtual CPUs, 4 gigs of RAM, etc. Amazon counts them as computing units, which is equivalent to something like 1.2 gigahertz Xeon processor from 2007. And Microsoft counts them as 1.6 gigahertz CPUs. Interesting to point out that even though we require 8 gigs of RAM, we can only get 7.5. So it's not really suited for us. And here are the prices, which are pretty low. So I would really go with these numbers. But if we do the math, the monthly cost would be $3,211 using Amazon, and roughly $3,000 if you're using Azure. And if we look at the annual costs, it would be tremendous. So well, of course, we decided to go with our own implementation. Our ROI is around 6 to 8 months, and we could even fit in some. So we were aiming for the 25 virtual instances, but instead we scaled up, and we managed to put in almost 100 instances on top load into that same price. I mean, the one that we returned, and yeah, but it's important to remember that there's no works every time solution. So this worked for us, but as I guess Eric mentioned, they were able to get it for $7,000 a year. So that's kind of like different. And okay, this is the last topic. I would like to show you how my team solved the testing in the cloud with open source tools and in-house cloud. So we write code in IntelliJ IDEA. We don't use GitLite, but we use GitLab. And so we push the code into GitLab. We have a Jenkins installation which we'll pull from Git. I've got some images for that. Okay, so IDEA. This is our GitLab instance. We have Jenkins to pull the source code, and it will execute a build and offline static analysis and testing and deployment at the same time. Of course, they are dependent on each other. This is where we have the Sonar is what we use for static code analysis. And for Harry's satisfaction, code complexity is decreasing by time. And we have TestNG and Synonym to do our functional testing. And so a little joke at the end, should we be afraid of? Yes, no, says the NSA. So thank you very much.